Hello everyone, Sebastian here. Unless you are happy with your game being fully represented with simple geometric shapes, drawing sprites on screen is an important part of game dev project. But it's not only about simple sprites. There is a lot of connected topics I have to think about straight away, just to make sure I won't paint myself into a corner. Specifically animations, maps and drawing priority. Lots of War won't use any really advanced techniques, but the diversity of topics evolved to justify making rendering the topic of this video rather than just sprite drawing, for example. Quite a lot to cover, so let's get started. Let's start with a single sprite of a unit. Yes, I know it's a prime example of programmer's art. I'm just going to pretend it's a representation of actual unit sprite made specifically to not distract anyone with my awesome pixel art skills. Right, so now that everyone finished laughing, let's talk unit sprites. Well, not that much to tell actually. Drawing units in Lots of War will be very basic, mostly because units will have a very short list of states they can be in. Most of the time they'll just be standing in place, and while moving they will have simple walk loop made out of few frames. Even in combat, actual units don't move at all, and entire visual feedback is handled with special effects. And speaking of special effects, those will be one-time sprite animations too, as simple as it gets. There is a complication here though. Special effects sprite needs to always be drawn on top of unit sprites. If drawn underneath, it will look bad or won't be seen at all. Actually, there is a lot of situation like this. Units needs to be drawn on top of ground, cities needs to be on top of ground but under units, while canopy of the trees needs to be drawn on top of units. Because you see, 2D games are like onions, they have layers. Or like cake, everyone likes cake, let's go with that. Here's Lord of War rendering cake. At the bottom there is a ground layer, which contains, well, ground, like grassy plains or volcanic ashlands, but also things like water for seas and rivers. On top of that there is a layer of terrain features, hills, mountains, forests, kinda. Next is a location layer. This includes all special places like dungeons, temples, ports. This layer also includes cities. On top of that we have units, and the last one will be forest meta layer. Forest is technically a terrain feature, but because of top-down perspective, trees canopy should be drawn over units, so I have this extra rendering pass here. In the future I will have user interface on top of all this, but this is something for future Sebastian to worry about. I'm especially curious how he will solve battle scenes. Oh well, I'm sure he will come up with something. Going back to presence, most of the implementations is in the viewpoint renderer. The central point of this new type is called the rendering task queue. It holds rendering tasks which describe all things that need to be drawn, which sprite, including which frame if applicable, and in what position on the screen. This queue separates the drawing process into two steps. Preparation step, during which it's decided what should be drawn and where, and actual drawing step, during which the drawing takes place at correct order. It all starts with sprite component, which holds graphical representation of entities. It also has the property of type, which will change how this particular sprite is rendered. During each draw call, viewport renderer will iterate through all entities, looking for sprite components. If sprite component is of type unit, then viewport will check if the unit is inside calling distance, and if yes, it will create a rendering task and add it to the rendering task queue. What's worth noting at this point is that rendering tasks in itself don't have any logic, it's just a data container. I explained word spaces and camera's local space in previous video, so now I just point out that the location that the rendering task stores is in camera's local space, which means it needs to be translated from the word space before it can be stored. If the sprite is of type map, then the process is more complicated, specifically because maps introduce third coordinate system, map space. This is because map in MicroStudio operate on the idea of point 00 being in the lower left corner, and coordinates use different units, that word space. to make translating between those two spaces easier, I'll always render map in a way that it's centered in the point 00 of workspace. While creating rendering task for a map, first I need to figure out which blocks are visible. For this, I'll translate camera's position into map space, then calculate calling distance and create a range of map blocks coordinates that should be currently visible by the camera. After that, I take the name of the sprite, translate its coordinates into world space and then into camera local space, and finally I add the rendering task of this particular block of the map. And then finally I do actual drawing, which is quite straightforward by this point. As long as there is an unhandled task in render queue, I just get the next one and draw it on the screen. All data were prepared in the previous step, so the actual drawing can be as simple as possible. The only interesting part is that getNextTask method. It internally removes and returns the rendering task one by one from the Lord of War rendering cake until there is nothing left. And this is the result. A panning camera that correctly cools both units and underlying map. Pretty neat, I think. So, now that I have this cool camera system, it would be even more cool if the units could actually move, so that's what I'll do next. See you in the next video.